Milecia McGregor, and I am a software engineer just like y'all. I'm from Tulsa, Oklahoma, so nowhere near around here. But I'm going to tell you guys about machine learning and how you can use it on your UI and UX. And we all know that Skynet is inevitable, so we might as well make it more custom for us. So, just a quick overview of what we'll be going through. I'll give you some background on neural networks, so by the time you leave this talk, you should have a good idea of what a neural network is and how you can use it. Then I'll go into a little bit about the Brain.js library. So how many of y'all have used TensorFlow.js or are familiar with it? Okay, that's more than usual. I'm glad. Then we'll get into actually building a machine learning model and what all goes into that, like how do you choose the features, where do you get the data, that kind of stuff. And I'll show you how to figure out how to make your model understand user behavior. So users are some of the weirdest people on the planet to understand, so we need a lot of help trying to figure out what the heck they want. And then we'll go over how you actually use your machine learning model to make updates to the DOM. That's the fun part. So let's just jump right into neural networks. They're basically just algorithms that can be used to make predictions. So a neural network is made up of a lot of layers of nodes, and a node is basically like this. The point of a node is to imitate a neuron in the brain. That's what it's supposed to do. So what you do, you have a node, you give it some inputs. So let's use housing as an example. Say you have a studio apartment in, I don't know, this area, so like, I don't know, PG County or something, and you want to know how that would relate to your specific property in that area. You would give the node different inputs, like the price, square footage, stuff like that, and you would assign these weight values to them. So each input gets its own weight, and that weight tells the node how important that particular input is to the overall prediction of what it's trying to figure out. And once you have the inputs and the weights, it goes through whichever kind of algorithm you choose. So that's where the real machine learning comes in, the real math-heavy stuff that we're not going to talk about today. And once it goes through all of the magic algorithmic stuff, you get an output that's basically the machine's prediction for what value you would expect given the inputs, the weights, and all of that good stuff. So how many of y'all have heard of the term deep learning? Do you know what it is? So, okay, I see somebody does. But to put it in a nutshell, deep learning just means you have more than one of these nodes in your neural network. Ta-da! That's all of machine learning demystified, but that's all deep learning is. And to implement it, like I said, you just have to have more than one of these nodes in your network. So let's talk a little bit about neural networks and web development in particular. So some of the things that you can do with machine learning in web development is predict stuff like user intent. So those pop-ups you see when you're about to exit a page, that can be taken to the next level times 10. So you could do things like look at where a user is looking at on your page based on their mouse coordinates and determine this user is looking at this section, so they probably want to be shown this thing or they want this thing to happen. That's a scenario with predicting user intent. Then another thing, back to our Skynet, you want it to be personalized for users, right? Everybody likes stuff that feels like it was custom made for them. So when you have a machine learning model, you can make those custom interfaces. So you could look at user data that you either aggregate over time or you could just buy some data somewhere. Apparently they do that as a thing, but you could get that data and figure out stuff like what kind of wording people want to see in chatbots, what color contrast they like on the page, where you should place elements for them, stuff like that. And also you can find ways to improve your UI UX. So if you have a model and you've trained it to look for bad users, so that person that's going to click on all of the wrong things all of the time and break prod immediately. So you can use a neural network to find those particular areas where people usually screw things up, and you can use the predictions to update your UI based on actual user feedback. But now, this is my favorite part. I love Brain.js. It's just a machine learning library that I definitely chose over TensorFlow. So there's a few reasons that I like Brain. First off, it's super easy to use. If you know how to make an array of objects and call a few methods, you can use this library. Unless you're trying to get, more hands-on with the algorithms and stuff. But if you need an implementation of machine learning in JavaScript, hands down, this is so easy to use and so easy to integrate. And it's just an open source product. Like, I don't work for anyone. It's just me nerding out over this library. And unlike with TensorFlow, you don't need as much knowledge on machine learning. If you're willing to get kind of a high-level overview of what the particular methods do, there's some pretty decent documentation, some videos. Next point. There's all of the stuff you need to get up and running without having ever touched any of the machine learning math. And we'll get into a little bit more about that later, but for the most part, unlike with TensorFlow, you don't need to know what tensors are, if they're 2D, 1D, all of the other weird specific things that TensorFlow does. And again, the tutorials are super straightforward, they're easy to follow, and by the time you finish them, you'll have a few small apps that you can build on. So this is where we get into building the model itself. How do you decide what features you're going to use to train your machine learning model? First thing, will this add value for a user? So is there something you're trying to predict in particular? Machine learning is not magic. You have to tell it what you want it to do. And you have to be really specific, or else you'll get an answer. It's just you might not know what question it's answering. But when you build your model, you intentionally want to make sure that the features you choose, so features are like inputs. So what is going to add value for the user? Is it going to make sense to do something like a recommender system for a blog site or an e-commerce site? Will it make sense for, I don't know, integrating into something else? What's going to make this model add value to a user? And then how do you actually get the data you need to train the model? Again, some companies have started buying data, which, privacy, ethics, that kind of stuff. But you can buy it, or you can get it straight from your users. You can set up functions where all they do is send data to your back end for later processing. So you could look at things like mouse coordinates or input text they use, stuff like that. And again, what are you trying to predict? So you have these inputs. You know that you want to update your UI based on, I don't know, the user's previous browsing history or something. But what do you want to know? That's the main question. Machine learning is cool and stuff, but what do you want? What do you want from it? That's the main thing you need to know too. And a big one, will the user care if we actually make this update? I'm sure you guys have worked on features and bugs that, well, nobody cared about. So you don't want to spend the time, the money, and just the manpower to make this crazy machine learning algorithm and get it super performant and all this other stuff if nobody's going to care, right? So this is how you choose features. Next, I'm going to try to be a little bit brave and show you guys some code so you can kind of see how you implement it in Brain.js. Okay. So I set up, oh, that actually looks really good up there. Sweet. So I set up just a little demo app. It doesn't do anything production worthy yet, but basically we just have a Node Express backend, and where it gets interesting is where we start bringing in our input data. So these numbers are all made up, so are the values. Everything's made up. You can replace any of this with anything in your wildest dreams. So what I'm going to check for is if there's a user on my site that's trying to do some kind of SQL injection using a text area or input box. So I have different values for certain words that a normal user probably wouldn't type in, and each of these inputs map to an output. So when you're first training a machine learning model, it doesn't know what to expect on the other side of your inputs. There's two versions. You have supervised machine learning and you have unsupervised. Unsupervised is really hard. That is not what this is, and that's not what a lot of machine learning is. Most of it is supervised learning. And that means you give your model some input data and you give it the corresponding output data as well. That way it learns what it should expect when it sees certain inputs from you. And that's what I've done here. So we just have a couple of arrays of objects for our original training data for the model. Then, yeah, like I said, it's not production, but we come down here and make just our initial training data array. So got a little, yeah, anyways. So we just make that array. You will have one object for your input values, and you'll have another object for those output values. And then, the moment you've been waiting for, this is how we this is how we set up a model using Brain.js. It's just an object. That's it. Where it gets a little bit more technical, if you do get into machine learning, you can use the different models that they have. Right now, I just chose the simple neural network because they're really easy to work with, but you could do like a recurring neural network or any of the other algorithmic models. And in this case, I wanted to do deep learning, so we gave it 3 whole hidden layers. That's 3 layers of nodes. That is it. That's really it. So we have our model made. And then the fun part is when we come down here and actually train it. That's it. That is how you train a machine learning model. You call the train method. And basically, that'll train it. And what these stats are, it outputs like your error margin, how many iterations it took to decrease that error, and it'll give you your resultant output. Then just give you kind of how I did getting the data from the user and updating the model. Basically what I did is the user, oh, I get to show you the fun part. Sorry. No, I don't get to show you that yet. Okay. But basically we just get a string from a user from a text area, we split it up into an array, and we basically make up values for those particular words. So again, you definitely have more math involved, but just for a quick overview. But after we get our user input, we send it through this stuff, and we just run the model, and that will give us our predicted output. So 2 methods, train, run, done. Okay, now, that you've seen all of the behind the scenes stuff, we can get into the fun part. How do you use this to actually make DOM updates? And the way that we do that is have this thing. First question, have y'all heard of Slipsum? Yes. Wait, somebody's heard of it?
Yeah, right here.
Yes.
That's what I think it is.
It probably is.
Samuel L. Jackson? Oh, yeah.
Oh, I don't have internet. Oh, that's unfortunate.
Navy Public.
No.
Not that one? Down to. Wait.
Navy Public.
Navy Public. Thank you guys. I promise Slipsum is definitely worth it. Is there a guest password?
That was from the bird theater.
Yeah, that was from the...
Close it.
Okay.
Refresh.
Enhance.
Windows, you might need to restart.
No. I guess Slipsum isn't gonna work, but basically it's a website where you can get Samuel L. Jackson quotes instead of lorem ipsum. It's pretty funny when you see the site itself. So if you can look up Slipsum, do that sometime. But basically what we're gonna do now is I'll show you just how simple it is for this model to figure out if there's a malicious user. Just to start with, let's say I want to select something. So most users aren't gonna type select in anything, right? That's a red flag. So what it does, at least right now, it just starts messing with the colors. And that lets the hacker or malicious user know, hey, I'm watching you. I know you're doing the stuff. But that's pretty much how this particular demo works. It just takes in different words and gives you a rating on if it's malicious or not. The thing about Brain.js, though, it runs on the server. There is a browser implementation, but, performance issues, for the most part, you want to run it on the server. And that's it in a nutshell. I'm really sad Slipsum stupid internet. But anyways, that's kind of how it works. Want to make sure I'm staying on time, so some key takeaways. First, try to find uncommon ways to implement machine learning, even if it's just a little personal project or you want to make Skynet and take over the world, whatever. Just look for different ways you can implement it. So you might work on a project where you have kind of like that, the weed thing. So you could use machine learning in that to figure out maybe potential yields given certain events that happen to the plants or the system as a whole. Then use Brain.js to handle web app machine learning, because hopefully going through that code kind of showed you guys how easy it is to implement. It's just a couple of arrays and a few function calls. The hardest part is going to be on you getting that data to train the model. And of course, we're always looking for ways to improve UI and UX, but try to find ways you can improve it on an individual level. Like maybe you make it more accessible for people who are hard of seeing, or you make it more accessible for people who have a hard time with touch screens, touch pads, or things like that. Think about some individual cases that you could possibly include in there. And once you find one, you can make a model out of it. But that is it for my talk. I did want to ask if you guys had any questions.
Questions. They are amazed.
Yes.
Can you, since it looks like it sets up the model at runtime, can you cache the model as well? So
Yeah, you can cache the model, or you can make a new model every time you run. It really depends on how how many resources you have available. Usually it doesn't take that long to run a model and get the data you need from it, but if you have, terabytes of data and you're trying to process all of that, AWS might not be too happy. You might not be too happy.